Okay, so here we have the hard-hitting question of a 12-kilogram piece of rock heading directly toward the moon. So here's the moon. Here's this chunk of rock. And it's heading directly toward the moon. And at 100 kilometers above the moon, by the way, this is definitely not to scale. Just drawing it this way for clarity. At 100 kilometers above the moon, so this is 100 kilometers there. It really would be very close to the surface as I've drawn it there. Above the moon, it's going 870 meters per second, right? And then the question is, how fast is it going? It must be going faster when it strikes the surface of the moon, right? So what is the speed that it strikes the surface, right? So when it's at a height of 100 kilometers and going 870 meters per second, its energy is, well, let's figure this out. So, well, it's definitely 1/2 12 times 870 squared. This is our kinetic energy, right? And then it's got potential energy that would be minus g times m1 right, times m2, which is 12 kilograms. And then we've got to figure out what this radius is, right? So notice it's 100 kilometers above the moon, right? That doesn't mean it's 100 from the center. So let's see. This radius is therefore going to be 100 times 10 to the third, right? Because it's kilometers. Plus, and then the radius of the moon, when you're at the surface of the moon, this is how far you are from the center, right? So 1.37, whoops, 1.737 E6, right? All right, so let's figure that out. That is, let's see, that's 10 to the 6th. This is, of course, 1.837 times 10 to the 6th meters, right? So that's what we put in here. Remember, it's just r, it's not r squared, because these are the energy formulas, right? Okay, so this is our potential energy. Remember, don't forget that all gravitational potentials are negative, and that's g. This is not, of course, 9.81. This is our 6.67 times 10 to the minus 11th, right? And then this is above the surface, and then striking the surface of the moon, it's got 1/2 12 v squared, and that's, of course, what we're trying to solve, right? What speed does it strike the surface? Plus the opposite of g, and then 7.35 E22 and 12. And then when it's at the surface of the moon, it's that far from the center, right? Okay, and now we're all set. Now we can solve for this v. One thing you could do, and what I will do here, is notice that in these problems, the mass cancels out. The mass of the move-it object, right? So all my calculations that I'm going to do here, I'm just going to get rid of that, right? So now let me do this left side here. 0.5 times 870 squared is 378450. And then this guy is the opposite of 6.67 E minus 11 times 7.35 E22 divided by 1.837 E6. So that term is, ooh, that's a big term, negative 2.668 726.184. Sorry about that, man. All right, here we go. So we got, so this is a positive energy. Remember, all gravitational potentials are negative. So it'll be 1/2 v squared, right? And then plus, and then let's figure out this term here. And I'm sufficiently lazy that I'm going to go up there and change that. So the opposite of 6.67 times 10 to the minus 11th times 7.35e22 divided by, and then the only difference here is that it's 1.737 times 10 to the 6th. And this is a even bigger negative, right? So it's negative 2 million. I don't even know what this, I think this is joules per kilogram is what we're doing here, are the units of this stuff. Then don't forget the 149. Okay, so now we're all set. Now we can just do these two sides, right? I'll add these guys up. I'm going to add this to the side, and then, we'll just do that math. Okay, so let's go this guy plus this guy. And then I'm going to put this guy on this side and make it positive. All right, here we go. And I have 532,089 is 1/2 v squared. Okay, so times 2 square root raised to the 0.5 is what I do. I get 1,031.59. All right, don't forget that's meters per second. It's going faster. This makes sense, right? It's going faster than it was above the surface. So just remember, it's just 1/2 mv squared plus the opposite of gmm over r on both sides. And then you have to figure out carefully what the r is or whatever, right? Pretty straightforward.